Okay, in this video I'm going to go over how to multiply rational expressions. You should probably watch the video that was on rational expressions simplifying before you look at this one here, but it's actually fairly similar to what I showed you in the previous video. Now remember that rational expressions are just ratios of polynomials or fractions made up of polynomials, right? And just like you would multiply, let's say, two fractions, something like, let's say, 1/2 times, I don't know, let's go with 4/3, okay? You can actually simplify this. You can multiply the numerators, multiply the denominators, and you'd end up with, what, 4/6. And then you could go ahead and factor this, 2 times 2, 2 times 3, and then take out any of the ones that you see. Doing it that way, and you're just left with an answer of 2/3 in the simplified form. Okay. Now that's the idea behind multiplying rational expressions, except that you probably want to do the simplifying as soon as you can, because multiplying those polynomials can really be tricky. All right. So let me show you what to do. Take each of the individual parts and factor them. So you recognize x squared minus 4 again is a difference of squares, don't you? So we'll just say x plus 2 times x minus 2. Down here, you'll see that as a trinomial with a leading coefficient of 1. So you go immediately to the back side and you say, okay, what two factors of -2 add up to a positive 1? And if you said x plus 2, x minus 1, you're correct. Okay? Now, in a way, when you're multiplying this becomes a little bit meaningless, doesn't it? I really could just rewrite those with parentheses around all of them and don't have to treat them individually, but I'm going to anyway. I'm just going to say that this x plus 2 just remains x plus 2 because I can't factor it any further, and this x minus 3 remains just x minus 3. Now notice that I can do that, and I can also do that and just put them really all under the same thing, because that's still being multiplied, isn't it? It's just a different way of rewriting it. And that's how I think sometimes people get into trouble. They don't see it quite that way. Now that I've got factored polynomial up in the numerator and in the denominator, I look for wherever I can cross out the ones. Now you'll notice that there's one right here. And that looks like it's pretty much it, doesn't it? So I'm going to leave that in this factored form. I'm going to say x minus 2 times x plus 2, and then over x minus 1 times x minus 3. Now a lot of students ask me, do I need to go ahead and FOIL those out? And you really don't. You want to leave them in factored form, okay? Leave in factored form, because there's really no further simplifying that you can do here. Now there's one last thing I want to show you here. Because I've got this, I also have what are called, I have to find what numbers are restricted from this problem. Now what do I mean by restricted? You'll notice that x minus 1, if x were 1, that would make this whole thing 0, which means I'd be multiplying the denominator. This whole thing down here would be 0, and I can't do that. So I have to say, this is the simplified form, but x cannot equal positive 1. Also, x cannot equal a positive 3. Right? Because otherwise this would be 0. And if I go up to the very, very top, and anywhere down the line, I'll notice that x also cannot equal a -2. Those are called restrictions, and you need to use these to have a complete answer. Okay? So again, these are called restrictions. All right, now I'm going to do one more problem for you. It's a little bit more complicated, okay? Let me just take that out of the way. And let's look at this one. Again, you'll notice it's the same thing, but the numbers are getting, the polynomials are getting a little bit more complicated in some respects, a little simpler in others, all right? Again, you treat them the same way. I'm noticing that this is a difference of cubes. Now, to remember how to do a difference of cubes, you do a binomial and then a trinomial. You take whatever the sign is, and that's what you start off with, and then you go opposite, and then you always end with a plus. Okay? Now let's go ahead and factor that. Remember, that was just 1 times 1 times 1, so I'm just going to put one of them there, and then 1 times 1 goes there. Go to the back end. It's x times x times x, so you put one of the x's there, and then the x times x, what's remaining, over here. And you put one of each right here. So 1 times x is just 1x. Okay? And then that's all divided by x squared. Now this is an x cubed here, so let's go put that there. And just like what we did in the last problem, we're going to do that because, again, it's just multiplying. And then I'm going to take this last part. Now, remember, you always ask yourself, this is a trinomial, are there any common factors first? And you'll notice that there is. There's an x there, isn't there? So let's go ahead and take out that x first, and then I'm left with 1 plus x squared. Now, you're probably noticing, oh, that's pretty convenient, and these are all, again, multiplied. So let's make sure that we put them into something that looks like that. Now, let's go ahead and start simplifying. Let's cross out any ones that we can. You'll see that 1 plus x squared, and then 1 plus x squared, that is a 1, so let's get rid of that one. I also noticed that there is a x squared, but there's also an x squared here. Actually, there's an x cubed down here, isn't there? Because x squared times x is x cubed. So we'll go x cubed, we'll take rid of that. And the only thing that's left is the 1 minus x. And that would be my final answer. Now, are there any restrictions here? Yeah, x cannot equal what number? What number would make this denominator equal to 0, or these denominators equal to 0? And the only thing that x cannot equal is 0. Okay, so I hope that was helpful to you. Look at these as many times as you need to.